Hooke's law states that the extension of an elastic object is directly proportional to the force applied, provided that the limit of proportionality is not exceeded. Now, generally in a classroom, to look at Hooke's law, we use springs, which are generally an elastic material. To prove that a spring obeys Hooke's law, we need to plot a force extension graph. And to get the data you need to plot this graph, you'll need to do an experiment where you add weights to a spring and see how much each weight extends the spring by. Now, in mathematics and in physics, we prove proportionality by drawing a graph and seeing if that graph is a straight line graph through the origin. If you have a straight line graph through the origin, it means that the x and y variables, in this case force and extension, are proportional to each other. So a straight line graph through the origin for a force extension graph proves that the material is elastic and is behaving according to Hooke's law. Now you see that this graph here is pretty much a straight line until a certain point here where it starts to curve. This is the limit of proportionality, and it's around about here. So a force extension graph can tell us two things. Firstly, whether the material behaves elastically, and secondly, where the limit of proportionality for that material is. After this point, when you take the weights off the spring, you'll find that the spring has been permanently distorted or permanently stretched. Now, Hooke's law can also be written mathematically like this: F equals KE, where F is the force applied, E is the extension, and K is something called the spring constant or the force constant. And we can work that out using the graph. Now, in maths, the general equation for a graph is y equals mx plus c, where m is the gradient of the graph and c is the y-intercept. Now, for the force extension graph here, and in fact for any force extension graph, if you have no force, there's no extension. So the y-intercept is at the origin, or at 0, so we can get rid of that. That means that for this graph, we just need to look at y equals mx, or y equals the gradient times x. For a force extension graph, the y value is f. The x value is extension. You can see that from this graph here. That means that m, the gradient, must be equal to k, the spring constant. So we can work out the spring constant of a spring or the force constant of any material by working out the gradient of a force extension graph.